Suppose that f is a one-to-one function defined by the following diagram. Therefore, function f assigns to each element of the set X one and only one element of the set Y. We can indicate this by writing that the function f assigns to element X element Y, or we can say that Y is the value of function at X. Function f is one-to-one, and therefore each element of y corresponds to only one element of x. Therefore, we can consider a relation that assigns to each element of y that one element of x, such that y is f of x. For example, we can assign to A 1, we can assign to B 2, we can assign to C 3, and we can assign to Y x. You can look at that relationship, which is kind of inverse of the function f, and you can notice that this relation is a function. To every element of the set Y, we assign one and only one element of the set X. This relation is a function which we call the inverse of f, and denote f with the superscript negative 1. So this is the inverse of f, and the notation is as said f with the superscript negative 1, and it's called f inverse. Therefore, we can say that f inverse takes the value of y and assigns to this value element x, or we can say that x is the value of f inverse at y. Clearly, there is a relation between those two functions and values x and y, and therefore we can say that x is f inverse of y. This is going to happen if and only if y is equal f of x. Because we usually use the inputs, denote inputs as x and outputs as y, we can rewrite this relationship in the following way. Y is f inverse of x if and only if the x is equal f of y. Function f inverse is the function obtained using function f, and therefore we can look for the domain of that new function. If you look at the diagram, you can see that the domain of the function f inverse is the set of outputs of the function f, and therefore domain of that new function is the range of f, the set of all values y for function f. We'll finish here with the definition, formal definition of the inverse function. We'll say that function g is the inverse of f if two conditions are satisfied. The first, the composition of f and g is identity function. It means that that function takes input x and returns as output the same value x. This is happening when x is in the domain of g. And the second condition is that composition g with f is also identity function, so it's on that value x is also x, but this time those x's are in the domain of f. We'll discuss other properties of the function and its inverse in the subsequent videos.